Hello students, welcome to my channel Explore Physics Let's Explore. Now we are going to solve the numerical problems based on mirrors. We'll be using the mirror formula and the magnification formula to solve the numerical problems. Before solving the numerical problems, I'll be giving you a few hints which will be very handy to you when you solve the problem. That is, for concave mirror, the shape is, that it is like this. This is P. According to new Cartesian sign convention, we have to measure all the distances from P. So, if the object is somewhere here, then it will be P O if the object is at O. So, P O. So, it is negative. So, U is always negative. Always negative because it's in front of the mirror, and you know that if this is the center of curvature and this is the principal focus, you remember that it's a part of a hollow sphere, and the center of C is center of that sphere, and half of that is F. You already know about it. So when we are going to find PF or PC, always that will be negative. So if I'm talking about focal length F, so F also will always be negative. So always negative for the concave mirror because F is PF. The incidence ray direction is this, so opposite of that is negative. Now let's talk about V, the distance between the mirror and the image. Only in one case, the image is behind the mirror, the case where the object is very close to the mirror, or when it is between F and P, then only the image will be virtual and erect. So, barring the one case, U will be negative, I'll write except one case. So, except one case, what is that case? When the object is between P and F, V also be negative. That is about the concave mirror. Now let's talk about the convex mirrors. So convex mirror is this way, it's like this. Say this is P. Now the center lies behind the mirror, the center of curvature, and so is F. So this is the focal length. Object will be placed somewhere here in front of the mirror. So U, that is the distance between the object and the pole, is always negative because the incident ray is in this direction, that is the positive direction, and we are going to find PO, that is U. So U will always negative for convex mirror as well. Let's talk about V. V will always be behind the mirror. So behind the mirror is somewhere here along the direction of incident ray. So remember that V always be positive for a convex mirror. So V is always positive for convex mirror. What about F? F is again behind the mirror in the same direction as the incident ray is. So F also will be positive. So F will always be positive. So we'll just recollect one more time. U for concave as well as for convex mirror always negative. F for concave mirror is negative. For convex mirror it is positive. V, barring one case, it's negative for concave mirror because all the images are in front of the mirror, which is opposite to the direction of incident ray. So barring one case, V is always negative, V is negative, whereas V is always positive for convex mirror. So for convex mirror, U only is negative, V and F are always positive. So U always negative, V and F always positive. For concave, U and F always negative, V other than when one case again is negative. So if you learn these things, it will be very easy for you to solve the numerical problems, because you have to put the sign to the U, V and F while using the mirror formula or for the magnification as well.
That's all for today. Stay healthy, stay safe, and a very big thank you to you all.